Happy families are all alike and unhappy families suffer in their own ways. Likewise, happy datasets are all alike, clean, tidy, and ready for analysis. But messy datasets? Each one is messy in its own chaotic way. That's not just me being poetic. It's straight from Leo Tolstoy, the great novelist, quoted in one of the most famous papers on data cleaning by Hadley Wickham. And it couldn't be more true when you're working in Tableau. In this video, we are diving into the art of cleaning and prepping your data the smart way. From using Tableau's data interpreter to removing clutter and to reshape your data from wide to long format. I'll show you how to go from chaos to clarity. We'll transform this messy dataset into a clear, engaging line chart that displays year-wise trends in adult unemployment, which is broken down by country and gender. First, let's quickly go over the agenda and see what exciting topics we are about to explore. We'll begin by exploring the unemployment dataset, which contains unemployment rate data for 189 countries, which are categorized by gender, male and female, and age groups such as children, youth, and adults from 2014 to 2024. Next, we will discuss the key research questions that analysts aim to answer using this dataset, and significance of these questions, and review a sample Tableau visualization that could serve as a potential solution. Following that, we will spend considerable time thoroughly analyzing the problems present in this messy dataset. We'll also supplement our understanding by referring to Hadley Wickham's tidy data paper, helping us develop a comprehensive view of common data issues and their possible practical solutions. Finally, in the action phase, we'll import this messy dataset into Tableau and begin the cleaning process using Tableau's built-in capabilities, such as removing unnecessary headers, data transformation, or pivoting and deleting missing values, and making data tidy and ready for visualization. Alright, let's get into it and start by understanding the data first. This global unemployment dataset was sourced from the International Labour Organization. It covers 189 countries and includes gender-specific data, male and female, across different age groups such as children's, which are under 15 years, youth 15 to 24 years, and adults 25 years and above. The dataset spans 11 years from 2014 to 2024 and records the unemployment rate for each category. In short, this is the global unemployment dataset recording unemployment rates by gender and age group for 189 countries from 2014 to 2024. Now let's discuss the key question we are focusing on, while keeping in mind a structured 5-step approach: defining the question, understanding its significance, outlining the solution approach, executing the technical implementation in Tableau, and finally driving important insights. The question under investigation is: how do adult unemployment rates by gender differ across countries over the period from 2014 to 2024? Take a moment to reflect on the question and ensure a clear understanding before we move forward. Cool? This question is important for the analyst because it enables cross-country comparison of labor market dynamics, highlights gender-based disparities in employment on global scale, and help assess the impact of policies, economic shocks, and cultural factors on employment trends. To build a solution approach, let's identify the specific fields required to build an effective visualization that address it. Take a brief pause and try to list all the necessary fields. As per the question, we will definitely need the country name, sex, and one of the age group fields to filter specifically for adults, which is 25 plus population in this dataset. In addition to these fields, we also need year and unemployment rate fields to complete the visualization. Since we are creating a trend chart, we'll first begin by placing the year field on the x-axis and unemployment rate field on the y-axis. Next, we will differentiate genders by placing the gender field onto the color shelf to generate separate lines for each gender. Finally, we'll apply filters to focus on a specific country and the adult age group. That makes sense, right? By following these steps, we will be able to create a clear and impactful visualization ready to generate insights that analysts are looking for. I hope this process is now crystal clear to you. But do you notice any red flags in the dataset? Earlier, I asked you to place year field on the x-axis. Do we actually have a dedicated year field in the dataset? No, right? Likewise, we place the unemployment rate field on the y-axis. Does the dataset contain a separate field for unemployment rate? The answer is again a no. So do you see the issue now? This is one of the fundamental problems with this dataset. While you might suggest manually dragging each individual year column on the x-axis, this approach is not only inefficient but also impractical. That's why Tableau doesn't support it. Imagine having hundreds of year-specific columns. Managing them this way would be nearly impossible. So while keeping the other columns as they are, what we need to do is transform the red highlighted columns, those representing individual years, into two separate columns, one for year and another for unemployment rate. This transformation will effectively resolve the structural issue the dataset is currently suffering from. Now let's visually explore how this transformation changes the structure of the dataset and understand what each row will represent after the data is reshaped. Well, if you observe the first row in the original dataset, it contains year-wise unemployment rates for Afghanistani female youth within the age group of 15 to 24 years. In the original dataset, all 11 year-wise unemployment rates for this row are arranged horizontally across separate columns. However, in the transformed dataset, these values are pivoted and placed vertically. Each year becomes a separate row. As a result of this transformation, we now have two distinct columns, which we have labeled as year and the other one as unemployment rate, providing a much cleaner and analysis-ready structure. Let's pause for a moment and closely examine the result of this transformation, focusing on how a single row in the original dataset is reshaped into 11 new rows in the transformed dataset. Once you are comfortable with this example, it becomes clear that the same transformation is systematically applied to every row in the original dataset, right? In data science terminology, the original dataset is referred to as wide format dataset, while the transformed version is known as long format dataset. Also, it is now evident that a single row in the wide format corresponds to 11 individual rows in the long format dataset, one for each year. This type of transformation is commonly referred to as melting or pivoting. So be attentive whenever you come across these terms. Now that we have transformed the data and have all the necessary fields ready, we can begin building the visualization as outlined in the solution approach. We can now start placing the transformed year field on the x-axis and the unemployment rate on the y-axis. This will produce a basic line chart showing year-wise variations in unemployment. Next, add the sex field to the color shelf to split the line into two, one for males and one for females. And finally, put the age group and the country field on the filter shelf, selecting the adults category and a specific country, such as Afghanistan, to arrive the final targeted visualization. Now let's shift gears and explore the same steps from a more technical or theoretical standpoint. This transformed or long format dataset is also referred to as tidy dataset. In a tidy dataset, each observation occupies its own row. For example, this selected data point from the original table represents a single observation. It answers only one specific question, which is, among youth females aged 15 to 24 in Afghanistan, what was the unemployment rate in year 2014? And the answer is 13.34%. And in tidy dataset, this distinct piece of information should be represented as its own individual row. Great! Now you have a clear understanding of what an observation is in the context of a tidy dataset. The second property of a tidy dataset is that each variable forms its own column. For example, in the original dataset, these 11 separate columns actually represent just two variables, year and unemployment rate. After the transformation, these are properly structured in two distinct columns in the tidy format. Great! Now that you have a solid understanding of both the practical and theoretical aspect, as well as the key properties of a tidy dataset, let's take this a step further by exploring best practices in data cleaning and transformation. Guided by this influential research paper, which is Tidy Data by Hadley Wickham, who is a renowned statistician, author, and researcher. In his work, Wickham re-emphasizes the critical role of data cleaning, highlighting that, on average, nearly 80% of data science projects' time is spent just preparing and cleaning the data. In this paper, Wickham outlines the definition and core properties of tidy data. He also delves into the most common issues found in the messy datasets and provides in-depth strategies for resolving them effectively. For example, one such issue our dataset is suffering from is column headers are values, not variable names, right? Because in a dataset, the column header represents specific values or individual years rather than the variable name year. This structure makes the dataset wide and non-tidy. So take the time to read this paper carefully, as it offers comprehensive understanding of the issues that messy datasets commonly face and their appropriate solutions. While the technical implementation in this paper is demonstrated using R programming language, if you're not into the R programming, you can safely ignore the technical implementation for now. In my other data science Python programming course, we'll gradually develop the technical skills needed to perform this transformation eventually. To simply put, this paper teaches you what needs to be done, and I'll teach you how to do it in Python. Awesome? You will find the PDF of this paper in the resource folder of this course. Before we move on to the technical implementation in Tableau and begin building the visualization for researchers, let's first take a moment to examine a few additional yet important issues that this dataset is currently facing. Here's how the dataset appears in Excel. One of the first things you will likely notice is the presence of this header text, which is a brief description about the dataset itself and is placed above the actual data table. This is problematic, as such metadata serves no role in Tableau visualization. If not removed, it can interfere with Tableau's ability to correctly interpret and analyze the data. Next, the most prominent issue, which we have already discussed in detail, is that column headers represent values instead of proper variable name. Notice as you scroll down, column names are no longer visible. While this isn't technically a data issue, but in Excel, it makes exploration and analysis more difficult. So let's quickly freeze this header row so it remains visible as we scroll down. To freeze this header row, select the entire row just below the column headers. Here it is row 7. Then navigate to the View tab in the menu bar and click on the Freeze Panes option. This ensures the top rows, including the column header, remain fixed in place for easier navigation throughout the dataset. Now, as we scroll through the dataset, another issue becomes evident: these missing or null values. For instance, in case of Ukraine, employment data is unavailable from 2022 onwards, likely due to ongoing conflict with a neighboring country. In this course, and for the purpose of this visualization, we'll simply remove the rows with missing values to maintain data consistency. However, in upcoming machine learning course, we'll delve into more advanced techniques for handling missing data. And finally, as you scroll further down, at the end of the sheet, we'll encounter additional descriptive text below the table. Since this content is not useful for visualization or analysis in Tableau, we'll need to remove it as a part of data cleaning process. Alright, let's quickly summarize these issues before jumping onto Tableau to clean this dataset and building visualization. First, the column header contains data values instead of proper variable names. Second, the dataset includes additional header and footer text that is not relevant for analysis. And lastly, there are missing values within the data that needs to be addressed. So without further delay, let's proceed to Tableau, import the data and begin by tidying the data and eventually building a visualization. To begin, open Tableau Public and select Microsoft Excel as a data source. Locate the file named Global Unemployment Data on your PC, select it and click the Open button. Once you are in, let's hide this metadata section for now by clicking on this horizontal drop-down. Since the dataset is in a messy format, the first thing to observe that the actual field names such as country, gender, age are located in the third row, while the first two rows contains descriptive text. As a result, Tableau has assigned default field names like F1, F2, F3 and so on. To remove this descriptive header and footer text efficiently, Tableau offers a built-in tool called Data Interpreter. By simply checking the Use Data Interpreter box, Tableau will automatically clean up those irrelevant rows and correctly identify the actual headers. As you can see, the data now displays correct field names, and the unnecessary descriptive text has been removed successfully. The Data Interpreter is a simple yet powerful tool. I encourage you to explore its full range of capabilities by searching for Tableau Data Interpreter on Google and visiting the first link. Here you will find detailed insights into the various data cleaning features this tool has to offer. Cool? Now let's focus on transforming this wide format dataset into a long format. Instead of having separate columns for each year, we'll consolidate them into two columns, one for year and another for unemployment rate. To begin, click the column header for the year 2014, then hold down the Shift key. While holding it, scroll to the right and click on the 2024 column header. This will select all the individual year columns in one go. Make sure you don't release the Shift key while scrolling. Now right-click on any of the selected year column and choose the pivot option. And just like that, we have successfully reshaped the data from wide to long format, exactly as we discussed earlier. Now let's rename these two newly transformed columns as year and unemployment rate. Now that we have cleaned the dataset by removing unnecessary descriptive text and reshaped it from wide to long format, let's jump into building the visualization that addresses a core question. Click on the Sheet 1 to enter the visualization canvas. Before we begin, let's quickly revisit the question and the approach for creating the visualization one more time. So just to revisit, we are trying to explore the central question, which is how do adults' unemployment trends by gender vary across countries from 2014 to 2024. And to build this visualization that answers this, we are going to need the following field: country name, sex, age group, year, and unemployment rate. And this is what a transformed dataset looks like. From here, let's start building the visualization. First, we'll drag the year field onto the column shelf. This will become our x-axis. Then we'll bring the unemployment rate field onto the row shelf. That gives us a basic line chart. Now the moment we drag the sex field onto the color, Tableau automatically splits the line into two, one for males and one for females. This gives us a clear gender-wise comparison over time. And finally, we then place country name and age category onto the filter shelf and select a specific country and the adult age group, just like we planned. And that's it. Let's now hop into Tableau and quickly implement everything step by step. Just like we discussed, let's drag year onto the column shelf and unemployment rate onto the row shelf. Since this year column was generated through a manual pivot transformation, Tableau recognizes it as a string by default. So that's why it initially displays a bar chart for each year instead of a default line chart. But no worries, to switch to a line chart, simply go to the Marks pane, open this drop down, which is set to automatic, and select line. This will instantly convert your view into a clear and continuous line chart. Now as planned, drag the sex field onto the color shelf in the marks pane. This will split the trend line into two, representing male and female unemployment rates. Next, we drag the age category field onto the filter shelf. In this filter dialog box, check only the adults option and click OK to apply the filter. Finally, drag the country name onto the filter shelf to enable filtering the visualization by a specific country. When the filter dialog appears, click on the All button to select all countries for now. Then hit OK to apply the filter. Now, to allow interactive selection of a specific country, right-click on the country name field in the filter shelf and choose the Show Filter. This will display a filter pane on the right side of your Tableau worksheet, where you can easily pick any country from the list. Also, let's switch the country filter from these multi-check boxes to a cleaner radio button style for selecting a single country at a time. To do this, click on the small drop-down in the filter pane and choose Single Value List. This will change the selection type to radio buttons, making it easier to focus on one country's visualization. Perfect! With this setup, you have built the core of your visualization. Now, by simply selecting a country from the list, you can clearly observe how unemployment rates have changed year by year for adult males and females for that specific country. This interactive design makes your insights both dynamic and easy to explore. Now, before we give this visualization its final aesthetic touch, let's address the last remaining data issue. Remember how some countries, like Ukraine, had missing values for unemployment rates starting from 2022 onwards? Let's fix that too. To see this issue in action, scroll down in the country filter and select Ukraine. You'll notice that from 2022 onwards, there is no unemployment data for 3 consecutive years. This results in 6 null values, 3 for adult males and 3 for adult females. Tableau also highlights this at the bottom right corner of the visualization. To remove the null values from the visualization itself, we'll use Tableau's Data Source Filter option. To start the process, click on the Data Source tab at the left bottom. Then on the top right, under the Filters option, hit this Add button. In the pop-up, click Add again and select the column that contains the missing values. In our case, that's the unemployment rate column, and click OK. Now pay attention to this checkbox at the bottom, which is labeled as Include Null Values. We want to leave this unchecked because checking it would keep the null values in the data. So essentially, we don't need to change anything in this dialog box. Just click OK, and in the next prompt, hit OK again, and the Tableau will filter out the null values for us. To verify that the null values has been successfully removed, let's go back to the visualization sheet and select Ukraine from the country filter. Notice how the x-axis only spans up to the year 2021. That's because we have filtered out the missing data for the years after that. Also, the message indicating the null values at the bottom right has disappeared, confirming the cleanup was successful. Cool. Now, if we select another country like Turkey, which doesn't have any missing values, you'll notice that the x-axis extends all the way to 2024 as expected. This contrast clearly shows how the presence or absence of null values affect the data displayed in the visualization. Awesome! Now that all 3 major data issues are sorted, descriptive text removed, data reshaped, and the null values handled, it's time to polish the visualization. Let's format it to make it clean, visually appealing, and ready for presentation. I'll begin by updating the title first. Double-click on it and enter a relevant heading like Gendered Unemployment Trends from 2014 to 2024. Make it bold and center aligned and hit OK. It looks good, but wouldn't it be even better if the selected country name, like Turkey, also appeared in the title, right? In other words, we'll now make the title dynamic based on the chosen country. To do this, once again double-click on the title. This time, type the exact field name, country name within the angle brackets, placing it before the main title and separating it with a colon like this. And the moment you click OK, the selected country name, like Turkey, instantly appears in the title. Now, as you switch between different countries using this filter, the title updates dynamically to reflect your selection. Pretty cool, right? Now let's make use of the most of the available chart space by selecting entire view from this fit drop-down in the toolbar. Also, we can clean up things a bit by hiding this label field for year, since x-axis is self-explanatory. Now let's enhance the visual appeal of the chart by updating the line color for gender. To do this, head over to the sex color legend, click on this small drop down and choose edit colors. I'm going with pink for female and this light teal for male, but feel free to pick colors that suit your preference. Once done, click OK. And lastly, I'm dragging the color legend above the country name filter to give it more visibility on the top. Alright, now let's also display the actual unemployment value directly onto the chart. To do this, drag the unemployment rate field onto the label shelf in the marks pane. Looking at these label numbers, it looks like we need to format them as well. Right-click on the unemployment rate field in the marks pane and then choose Format. First, go to the Font tab, make the text a bit bold and change the color to blue for a neat look. Now go to the Numbers tab and choose the Number Custom. Format the number up to 1 decimal place. Since this number represents the percentage of the population unemployed in that specific category, we can add a percentage symbol as a suffix in front of these numbers to clearly indicate that they are percentages. Great. Now close the formatting pane and take a look. The visualization already looks much more polished and professional. Let me make few more quick tweaks and fast forward the process for you. Feel free to add your own formatting style and personalize the visualization to match your preference. I'm going to quickly remove these horizontal grid lines, rename the y-axis, and slightly increase the size of these tick marks on both axes, and other minor tweaks. So enjoy the formatting. Looks good, right? And that wraps up our visualization. As always, you can find the published version of this visualization on a course homepage on Tableau Public. In the next video, we'll dive into some essential statistical plots, including histogram, box plots, and scatter plots, along with a brief introduction to probability distributions and its elementary mathematical applications. So stay tuned, and I'll see you in the next one.